Hello everyone, this is module KV7006 Machine Learning. Today's video is about one of major classification methods called random forest. So, in our previous topic regarding to classification, we already know what is CART, okay? Just to remind you, is classifications and regression trees. So we already learned classification trees in previous video. So in our previous video, we also talked about the bagging, but today we will explain a little bit more regarding to random forest method. So in classification, we know decision tree can grow, right? Can be very complicated, especially if we have many features, or the features have different, not binary. There could be real numbers, so there could be many ways to divide real number features. Binary just yes or no, but the real data, real number will be much more complicated. So they could divide it on larger than or smaller than or larger or small in any point of the range of the features. So that will be more complicated. In that case, you will see the tree can grow almost indefinitely. And then the purpose of random forest is to try to improve the prediction accuracy. And then the way to encourage improvement of accuracy is to encourage diversity among trees. So which introduce some random search in the search space. So we will search some space which we haven't done before. So you could imagine a tree is kind of a search in the overall search space. So random decision tree, we have R before the CART, classification and regression tree. So bagging, in our previous video, we mentioned that the bagging is kind of aggregation. Imagine I got several classification trees which have very high variance among them. So we use kind of aggregation to find average or typical trees. This is to avoid overfitting. As we mentioned before, overfitting is a scenario the trees or model perfectly fit to the training dataset. However, the learned model are not good enough. If we find a new object come in, the performance could be low. Because when trees are not cutted or not unpruned, which means that keep the original tree in learning process. So one hand, it could be very complicated. But on the other hand, it will be overfitting. So we want to improve the stability and accuracy. So there are two steps we will see pseudocode later on. We will have a sample set and aggregation. Sample set means we got a set of trees or subtrees. So I'll explain in the next slide. Okay, bootstrapped. Imagine my originally learning datasets have P samples. P, you could imagine, is population. It's the total number of the data sample I have in the learning set. So I divided them to K learning sets. So I divided them. So each composed of Q samples you can see Q is less or equivalent population. So most of cases we have smaller size than the whole population, the whole data set. Okay, and then we then obtained by uniform sampling. Do you know uniform sampling? Uniform distribution, which is randomness. Actually, it's randomness with a replacement from the total learning set. The total learning set. So we replace some sample with some sample in the total learning set. This is kind of bring some randomness in the data set, in the whole data set, which will have us search or find some new ways in the search space. So, which means in this one, if I replace from the total learning set with some set, it may contain repeated samples. For example, I replace some samples with some samples which I already have. So by this means you will have two identical samples in the sub-learning set. Let's call sub-learning set. So the random forest in that situation is my sub-learning set is equivalent to population set. So in my sub-learning set, we can approximately 63%, and the rest of samples of the total learning set can be used for testing. So during the test, we will evaluate how accuracy the output from the random forest method would be. So for each subset, one of the sub-learning set, LK, we will generate one classifier. So imagine it's a tree. It's a random forest classification tree for each of them. So we have L1, L2, L3, L4, L5, for example. So then for each one, I have one classifier. So I have C1, C2, C4, C5, for example. I have 5. Let's say I have 5 classifiers. They each match with a subset of the total learning set. Okay, most of the cases they are smaller than P. Okay. Now we have new sample come in now. So I got the 5 classifier. The way to do aggregation, there are many ways to do aggregation. I'm just giving you a simple example on how to do aggregation. So I will then have a majority vote among the predictions. For example, remember we got classification tree in the previous video. You can see from roots to each layer we have branches. So when a new sample come in, I will put into my classifier, okay? And then they will tell me this is class apple, this is class orange, this is class banana, this is class pineapple. And then I do a voting. If two of my 5 classifier say this is apple, and the rest 3 are saying different fruit, then I take apple. So the majority will vote. You may ask me, if the 5 classifier each tell me there's different things, what should I do? This is a good question. These relevant two things. One is the data set, one is K. So the K is something we have defined in here, right? We generate K-learning set. K is something we defined ourselves. Another thing is about the data set. So in case you only have 5 classes in your original data, if we are not consider situation, the new object is actually belong to a new class which we haven't seen before. We ignore that situation. It's probably that is in the scope of data stream mining. Let's say previously I got 5 different fruit. I got historical data for learning, for training. Now, over time, I've got a new fruit come in, for example, and then we couldn't use traditional way of doing that because this is a class we have never seen before. So that is out of scope, okay? And okay, imagine I got 5 classes, okay? And then if I choose K is also 5, it will have some chance that my 5 classifier use random forest generate 5 different classes, and also I got 5 real classes. So each have 1 vote. And this is a research question. So is a research determine what the best value K I need to make in order to avoid such a situation. So in order to make sure you be able to get a majority vote. Okay. So let's move on. So in principle, if we design value of K properly, according to how many classes we actually have in the training data set, normally you get a majority vote, which often you got. Let's say we have 3 classes in the original data set. We have K as the value we have chosen here to learn K learning set. You can see that we definitely got 1 class is dominant in the out of 5 because we only have 3 classes. Okay. So this is the pseudocode we try to use for the random decision tree. Is an internal mechanism. So first, all labeled center initially assigned to root nodes. And for each root node, we do the following. Okay. Find the feature 1 among random subset of features. So randomly select a subset of features and a set of threshold value, and then split the sample to n into 2 subsets, left and right. Okay, and then we try to maximize the label priority with this subset, and repeat that again. And if they are too small to split, and then you attach leaf nodes. Leaf nodes means the end nodes. Leaf nodes means the node which leaf nodes which are the nodes which we can further growth. We cannot further growth. Okay, and the tag leaves with the most recent level, and then respectively. And otherwise, if they are not too small, they are very separate to each other, we can attach each node, child node to n, and assign this to them, and repeat the procedure. So end of the day, a subset of features are randomly drawn from repeated at each node. So if there's multi-dimensional, we can calculate the subset size, use this formula. So this increase our diversity and also at the same time reduce the computational load. So Gini index we have already learned, which originally help us to define purity and equality. So now look at the summary of different kind of the classification method we have learned so far. Random forest, classification trees, k-nearest neighborhood, SVM. So we look at this column. Random forest can use for multi-class. So several class labels, we can manage that. And we can also handle the example I have mentioned, apple or orange features. So outlier probably already know. If we have a normal distribution, outlier is normally on the far end of the data set. Traditionally, we use 5% as a sample, which is outside the boundary, in the boundary of the data set. So we think 5% sample is outlier. Normally, we can remove them if we want to build a model. The outlier comes from the, if a sensor data, normally we have a mechanical fault, out of power, this kind of situation. So this happens in the real world data set. So we prefer larger learning sets. And the accuracy is good, and we can also attune to parameters. So there's some limitations in the random forest. So you could see when we try to divide 1, 2, 3, 4 classes, you could see have some staircase effect. So because we introduced something randomness or repeated sample randomly chosen from original dataset, they have probably more hyperplan than we probably originally think. So we could think fundamentally, can we make them a curve to divide datasets? Would it be better to model rather than this kind of multiple hyperplanes, too many hyperplanes to divide them as a staircase? Probably we can have linear or other model to divide them. Could be functionally simple. So that is random forest is quite a common method, which we could also use a lot of packages. It's a very well-known textbook classification method, which is quite popular. So you will find a lot of packages in many machine learning packages. Thank you for your attention. I'll see you in another video.